8.6, quadratic equations that are perfect squares. Okay, unlike difference of squares, we have three terms. We have trinomials here. So we have two formulas. We're to basically say that a plus b squared is equal to a squared plus 2ab plus b squared. And it works the same with minus. So what we're looking for as we factor these is that both parentheses are the same. And if that's the case, we have a perfect square trinomial. So we have in the beginning x squared and 36. Well, x squared is x times x. 36 is 6 times 6. And 6 plus 6 does make 12. But it's a negative 12, so I'm going to make both of them negative. And it works, because negative 6 and negative 6 makes negative 12. And negative 6 times negative 6 is 36. But we don't waste time writing it this way. We simply write one parenthesis, x minus 6, squared. Make sure that you only write the factor once with a squared after it. That means it's a perfect square trinomial. Now B's here is for you to try. If you think you can do B, you should pause now and attempt it. Well, where you fold, this is not a perfect square. Negative 49. A and A. But the way you get negative 49 is a negative 7 and a positive 7. But negative 7 and positive 7 don't make 14. So B, as it's written, cannot be done. It's prime. It is not a perfect square trinomial. So when asked, is it a perfect square trinomial? You would say, no, it's not a perfect square trinomial. However, if I was to change the 49 into a positive 49, now I can do the problem. Because 7 plus 7 makes 14, and 7 times 7 is 49. Now remember, you're not allowed to change the number in the problem. I'm just showing you that if it was a plus, then you would have been able to do the problem. And you would have written a plus 7 squared. Okay? All right, here's a couple more examples on the next page. All right, these should be perfect square trinomials. Remember, there's one thing that you always do first. Look and see if you can, that's right, divide. If not, start trying perfect squares. So go ahead and pause here and do as many of these as you can. All right, so 25 is a perfect square. 5 times 5. 5 plus 5 makes 10. So it works. But don't write it twice. Write it once with a squared. Now, some people take D and they'll say, like, oh, look, 4x squared. That's 2x. 2x. 36. Hey, that's 6 times 6. Make the 2 negative. Hey, look, they're the same. But you forgot something. If you can divide, you're expected to divide. All of these numbers could have been divided by 4. So I hope you did that. Cancel out the 4. X squared minus 6x plus 9. And then ask yourself, what times what is 9? Hey, it's 3 and 3. How do you get negative 6? You make both of them negative. So our factor will be x minus 3, x minus 3. But don't forget, write it once. X minus 3 squared. And all the time, that 4 needs to stay in the front. E, 2 times 2. Hey, 9 is 3 times 3. Perfect squares. 3y, 3y. 2 and 2. The middle number is negative, so I'm going to put two negatives there. Now, if you're thinking, hey, 2 plus 2 doesn't make 12. Well, you're right. But if you check the inside and the outside, 3 times 2 is negative 6. 3 times 2 is negative 6. And you know what two negative 6's make? Negative 12. So it does work. But remember, only write it once with a squared. And the last one, 2 times 2, 9 times 9. So 2t, 2t. 3, 3. Middle's negative, make two negatives. Double check that you get 36 by doing 2 times 3. Oh, that's not 3, I'm sorry. Those were 9s. I was square rooting it twice. So those were 9s. So 2 times 9 will make the negative 18. Another 2 times 9 makes the second one. Hey, that makes negative 36, which is the number in the middle. So don't forget, write it once. 2t minus 9 squared. And that's how you factor perfect square trinomials. If you get the same parenthesis for both of them, write it once with a squared. Okay? All right. Hope this was helpful.